So in this video, we're going to look at analytically finding a limit of a rational function when the denominator of the rational function isn't going to zero out under the limiting condition. And so in this case, we have a rational function, x squared minus 3x plus 2. We have a polynomial numerator divided by x minus 2, a polynomial denominator, which is what makes this a rational function. And the first step when you're doing analytically finding the limit of this type of a function is to look at the limiting number, which is 3. We want to take the limit as x goes to 3. You want to mentally plug that number into the denominator and see if it causes a division by 0. 3 minus 2 is 1, which isn't 0, and the moment you see that you don't get division by 0 if you were to plug the 3 into the denominator, that means you get to use this tool to find the limit. This says the limit as x goes to a of a ratio of two functions is the ratio of the limit of the two functions. So the first step in solving this particular problem is to first rewrite completely the problem, which is what you're expected to do in the homework. So the limit as x goes to 3 of the rational function, which is x squared minus 3x plus 2 all over the x minus 2. And because plugging 3 in wouldn't cause division by 0, I'm going to use this tool here. And I'm going to rewrite it as the limit as x goes to 3 of the numerator, which is x squared minus 3x plus 2. And I need to put that numerator in parentheses, implying that I'm taking the limit of each of the three functions there. And this is divided by, I'm going to take the limit as x goes to 3 of the denominator in parentheses. So that's step 1. Step 2 is then to recognize that in the numerator and the denominator I have the sums and differences of functions, which means I'm going to take this tool, which is distorted here in this image, the limit as x goes to a of a sum or difference of two functions is just the sum or difference of the limits. So we're going to use this tool to rewrite the numerator and the denominator. So I'm going to rewrite the numerator as the limit of the sum or differences of the individual functions. So the limit as x goes to 3 of the x squared minus, bring that minus down, I'm going to take the limit as x goes to 3 of the 3x plus, bring that plus down, and then I'm going to take the limit as x goes to 3 of the 2. The limit as x goes to 3 of the 2 over, and I'm going to rewrite the denominator as the difference of the limits of the two functions, the x and the 2. So the limit as x goes to 3 of x minus the limit as x goes to 3 of 2. And we are doing this in a lot of detail, and in homework 3, you are expected to show this level of detail. When we move into future homework assignments, we won't need to show this level of detail. So then I want to look at this first term in the numerator here, and I want to recognize that x squared is x times x. So I have the product of two functions, x times x, which means I can use this tool, which says if I have the limit of a product, I can take the product of the individual limits. So I'm going to rewrite this term here as the limit as x goes to 3 of x times the limit as x goes to 3 of x, because x times x is my x squared, minus, now I have a constant times a function x, so I can use this tool, which says if I have the limit as x goes to a real number of a constant times a function, I can multiply the constant times the limit of the function. So this is going to be rewritten here as 3, the constant, times the limit as x goes to 3 of the function x, plus, here I have the limit as x goes to 3 of a constant. And that means I get to apply this tool here, which says if I want to take the limit as x goes to any real number of a constant, I just get the constant. So I'm going to get plus, the limit as x goes to 3 of the constant 2 is just going to be the constant 2, divided by, now the denominator, I have the limit as x goes to 3 of x, which means I can use this tool. The limit as x goes to any real number of the function x is just the real number that you're working with. So the limit as x goes to 3 of x is just 3 using this tool here. Minus, I have the limit as x goes to 3 of 2. This is the limit as x goes to 3 of a constant, so you just get the constant too using this tool here. Now we want to keep working through. So we have limit as x goes to 3 of x, which means we get to use this tool again. The limit as x goes to any real number of x is the real number. So the limit as x goes to 3 of x is just 3. So we get 3 times, and we have the same thing again, the limit as x goes to 3 of x, which is just 3, minus 3 times the limit as x goes to 3 of x is going to give us a 3 again, just like it did here and here. And I have my plus 2 sitting there, so plus 2. And here in the denominator, I have 3 minus 2, which is just 1. And now I have just real numbers sitting here, so I'm going to apply the operations using order of operations. I have 3 times 3 is 9, minus 3 times 3 is 9, plus 2 over 1 is going to be 0 plus 2 is 2 over 1 is just 2. So the limit of this rational function is equal to 2 when we take the limit as x goes to 3.